Welcome to our course on medical sensor technology, and this is our first lecture, and we are going to introduce the medical sensor technology course. Okay, so this medical sensor technology, okay, so it is basically, it is the study of how sensors are used to measure, monitor, and analyze biological and physical signals for healthcare applications. Okay, so basically we will be talking about sensors. Okay, sensors and transducers. Okay, we'll be talking about these two things. Okay, how we use them in what, how we use them in the medical field. Okay, in the medical field, or you know in the health field. Okay, okay, now, so what is the first question is, what is a sensor or what is a transducer? Okay, so sensor is something which measures the physical input and converts it into electrical output. Okay, which is further processed to get desired output. Okay, for example, now sensor is something which measures, for example, let me talk about microphone first. Okay, now, the microphone that I am using right now, or that you use, what it does, it records the sound, right? It records the sound. Okay, so how does it do that? Basically, in the microphone we have transducers, or in simple way there are sensors. Okay, so there are sensors. Okay, and what do? They can, they can detect the sound. Okay, sound is a physical, okay, sound is a physical input. Okay, so the sensor, what it does, let us say this is microphone. Okay, this is microphone. So the sound is what it is, it is a physical input. Okay, physical input. Okay, so this is the reason we call sensors as an input device. Okay, for example, in computer, the mouse, the pointer, the keyboard, they are input devices because you can input the characters. Okay, or you can input the instruction. Similarly, this microphone is an input device. Okay, so the sound, okay, it is a physical. So what it does, it have a sensor inside. Okay, so the sensor detects. Okay, so it detects, what does it detect? It detects this sound. Okay, so it detects the physical quantity, physical input, and this microphone, it records. Okay, it means it converts it into electric signal, right? Electric signal. Okay, because the wire that is connected to the microphone, right, then that sound, it is converted into electric signal, and this electric signal is carried into your the computer or whatever you have connected it. Okay, similarly, these sensors, what are these? They measure physical input. Okay, just like the sound is measured by what? Microphone, right? And converts it into electric. Okay, so the electric output. Okay, which is further processed. Okay, now, by the way, it doesn't get right away carried to this wire. Okay, basically there are also the processors. Okay, which kind of if there is some noise in the noise in the sound, or if the if the sound is not, the amplitude is not that great. Okay, so it amplifies the sound. Okay, so in short, we have also the processor. Okay, they process this sound. Okay, so this is the reason we call it as transducer. Okay, so sensor after sensor, we have the signal processing. Okay, so all of it together, it becomes a transducer. Okay, so transducer is basically sensor with other instrument, to what, to clear the noise. Okay, to clear the noise, because the maybe the input have noise. Okay, and maybe it increases the amplitude. Okay, it means it strengthens the the input signal. Okay, it increases the magnitude of the signal. Okay, and it also clears some noise. Okay, and how much noise, it depends on the quality of the sensor. Okay, so this sensor plus this other instrument for signal processing, these two together we call it as a transducer. Okay, so all of it becomes a transducer. Okay, so in a transducer, the we have sensor and this signal processing device, right? So now, because we are in this medical sensor technology course, so we will not be talking about microphone, but it was just as an introduction. Okay, so let us talk about blood pressure monitor. Okay, now the reason I will talk about this blood pressure monitor is because in the medical sensor technology, okay, most of the devices like USG, electrocardiograph, the blood pressure monitor, they work on the the same kind of the chain. The steps are the same. Okay, so the reason I will explain the blood pressure monitor, I will explain it in a bit depth. Okay, because that is the, like, it is a the blueprint of all the devices which we use in the healthcare. Okay, in the medical sensor technology. Okay, so let us talk about blood pressure monitor. Okay, now what is the use of blood pressure monitor? Now, and another reason I use this, because it is very common, right? Blood pressure machine, the blood pressure monitor, right? Maybe nowadays it's in home. Okay, everyone carries every home, okay, nowadays carry this blood pressure monitor. Okay, digital blood pressure monitor. Okay, so I will be talking about digital blood pressure monitor. Okay, so what it does, it measures the internal blood pressure using transducer which contains sensors. Okay, so we know what is the use of blood pressure monitor. We can measure the blood pressure, okay, inside our inside our body. Okay, so let us talk about this blood pressure monitor. Okay, now this is a typical digital blood pressure monitor which nowadays is used in homes, okay, and in hospitals too. Okay, now what it does, okay, so in all the in all the devices in medical sensor technology, the first thing is measure rand. Okay, the first thing is measure rand. Okay, so let me write it here. So the first thing is measure rand. Okay, so the first question is always, what are we measuring? Okay, this is the first question. Okay, what are we measuring? Okay, what are we measuring? So if we have this blood pressure monitor, obviously we want to measure the blood pressure in the artery, right? So what are we measuring? This thing is what is called as measure rand. Okay, so if we are measuring blood pressure, the measurement is blood pressure in artery. Okay, so for example, if we want to measure the electric potential of the heart, okay, then it is ECG. Okay, then in ECG the measurement is electric potential of the heart. Okay, so similarly we have USG and all those things. In all these devices in medical sensor technology, the measurement changes. Okay, so this thing changes, right? Okay, but the process before and after remains the same, right? So the process is this from top to bottom. Okay, and it is common to all. Okay, so the measurement, now when we talk about this blood pressure monitor, okay, like this, we want to measure the blood pressure, right? So our measurement is blood pressure. Okay, now let us move to second step. Okay, now we call this as cuff. Okay, CUFF. Now you might be aware that like if we have a person, okay, so this cuff, it is wrapped around this, right? Okay, it is wrapped around this, right? So what it does, why do we wrap it? And in fact we wrap it a bit tight. Okay, why? So that the pressure, the blood is in the arteries. Okay, so if this is an artery, the blood is flowing. Okay, So this blood exerts pressure on the walls of the artery. Okay, so we have pressure inside our arteries. Okay, now when we wrap this cuff around our arm, the artery pressure is transferred to this cuff, right, to this cuff. Okay, now this cuff, okay, so we measure this. Now this cuff have, you know, sensors. Okay, sensor. Okay, so the sensor inside this cuff, what it does, it have you know, which kind of sensor, basically, you know, I told you we have sensor plus some, you know, signal clearing, right, signal improvement. So we also call it as transducer. Okay, transducer. So this thing have transducer. Okay, so it is not important, let us say it only have a sensor. Okay, because, you know, the signal processing, the signal cleaning, you can also do it when it reaches here. Okay, so now let us I don't know, let us assume that the transducer is here. Okay, transducer. Okay, I mean the, you know, the sensor plus the signal processing, okay, unit is in this cuff. Okay, so what it will do, you know, the pressure in the arteries, it is transferred to this cuff. Okay, the pressure, it is a physical input, right, physical input, right, the pressure of these arteries, the blood pressure inside us is a physical input. Okay, so the sensor detects this physical input, right, and it converts it into electrical. Okay, and this electrical is cleared. Okay, and it is, you know, then what happens, then we have signal conditioning. Okay, so that, you know, signal conditioning is this. Okay, so that I talked before. Okay, this signal processing, or we call it as signal conditioning. Okay, this is just a fancy word, nothing else. Okay, basically we remove the noise in signal conditioning, and because the signal is low, right, the low signal is, you know, the amplitude is increased. Okay, so that the low signal is converted into a high signal. Okay, so that we can, you know, measure it properly. Okay, if the signal is too low, maybe we will not detect, you know, we will not be able to measure it correctly. Okay, and the noise is very important, we have to remove also the noise. Okay, now where does this noise come from? That is you know, basically this lecture, today's lecture is basically, you know, I want you to, you know, kind of, I want to, you know, bring in the curiosity in you. You will see these things, noise, how do we reduce the noise, right? There will be, you know, when you read, when you go through this lecture, a lot of questions will come into your mind, and this is what I want. Questions like how to remove noise, right? Isn't this the question? Now, how to increase amplitude, right? How to increase amplitude of the signal. Okay, now how do these sensors work? Okay, sensors work, how do they work? All of these questions will rise in your mind, and this is what I want, because this is an introduction. Okay, so all of these things, that these questions, you might have a lot of questions in your mind, and in the coming lectures all of this will be, you know, we will talk each and everything. Okay, so right now this is just a curiosity increaser lecture. Okay, I want to arouse curiosity in you. Anyways, now the blood pressure, you know, basically the blood pressure is the pressure detected by sensor. Okay, it is very small. Okay, now when it gets, you know, when it gets converted into an electric, because sensor converts it into an electric. Okay, like volts. Okay, now this voltage is low. Okay, because the pressure measured by this is, you know, very low. Now we want more voltage, right? We want a high voltage, and how do we do that? We get it by amplification. Okay, now this, there is also some noise. Okay, so we filter something. Okay, and it comes, so the question is, how do we filter? Okay, how do we amplify? Okay, as I have told you, so it all comes in signal conditioning or signal processing. Okay, now let us say we have cleared the noise. Okay, and you know, we have amplified the magnitude, okay, of our sensor voltage. Okay, so from the transducer we got you know, no noise. Okay, because when the output from transducer have no noise or little noise. Okay, depending on the quality of the transducer. So let us assume ideally no noise, we got output from this. Okay, now this physical input was with noise, right? Noise and low amplitude or low voltage. Okay, so it goes into signal sensor, then there is another device inside it, the processing, signal conditioning. Okay, so it has deleted the noise and it has increased the amplitude. Okay, so the amplitude is increased. Now it goes into this, right, this device. Okay, now what it does here, now we know what is inside this. Inside this is a microchip, right, or a microprocessor, right? Now we know what is a microprocessor. It is a computer, right? Yeah, it is just a tiny computer, but the thing is that it is a computer. The microprocessor, the microchip in this is computer. Okay, now what we want our signal, right, with deleted noise and increased amplitude. Okay, so we have now a good signal, right? What we want this machine, this blood pressure monitor, to understand this. But remember, it is electric, right? Electric signal. Okay, we want this machine to understand this electric signal, which is very good, which has no noise. Okay, but the problem here is, we know the microchip, which is a computer, it does not understand electric signal, right? So what we need to convert it into something that the computer can understand, the microchip can understand, right? And we know, what does it understand? What does a computer understand? It understands zeros and ones, right? Zeros and ones, the binary system, right? The computer, the processors do not understand electric signal, they understand the digital, right? The binary, or we call it as digital, right? Because these are 0 and 1, they are digits. Okay, so there is one thing, the converter, okay, which converts this good signal, okay, converter into digital. Okay, so all it is installed in this instrument. Okay, now we have digital version. Okay, now we have this 0 and 1. Okay, now the problem is, if we just put this 0 1 0 1 0 1, all of this here, we will not understand, we will get confused. Okay, now we need a natural language, right? We want this machine to now understand this zeros and ones that it got from the electric signal. Okay, now again, another instrument in this, basically the software installed in this will convert this binary, these digits, into what? Into these numbers. Okay, that you see, the pressure. Okay, the systolic and diastolic pressure. Okay, the values that you see. Okay, this is human understandable language. Okay, so then it means there is another processor or the software. Okay, so this is how we finally get the the input values here. Okay, so if I write here, so first we have cuff pressure, right? No, we have blood pressure, right? Blood pressure, right? Now it have noise. Okay, not the blood, the blood does not have noise, the signal. Okay, the blood pressure signal, right? It have noise and low amplitude. Okay, all right. So the sensor in what? Sensor in cuff, CUFF. Okay, this is the cuff. Okay, it detects this blood pressure signal. Okay, so it detects. Okay, it detects, but the problem is, it have what? Again, it has the same problems. Okay, noise and low amplitude. Okay, now we have another device here, we call it as signal conditioning. Okay, signal conditioning or processing, whatever you call it. What it will do, it will be, it will give us again an electric signal, right? Signal, by the way, we also call it as analog signal. Okay, anyways, now the electric signal, its noise will be deleted, right? No noise, and the amplitude will be increased, right? Okay, now, but again the problem is the the processor, the microprocessor in our blood monitoring device will not understand, because the computers don't understand electric signal, they understand the digits, right? Binary, zeros and ones. Okay, so another instrument, okay, another device, okay, we call it as it is here ADC, okay, analog to digital converter, okay, ADC. Okay, so we have another device here, all of this is packed inside it. Okay, so ADC, what it does, it converts this electric signal into zeros and ones. Okay, for example like this, but not just this, a lot of these. Okay, now the computer can understand this. Okay, now when the computer can understand this, it will go through the software, the algorithm, the program inside it. Okay, it will convert it into human readable language. Okay, for example, pressure of, for example, 110. Okay, and for example 80. Okay, and this gets what displayed. Okay, and finally we have that thing here. Okay, let you see here, this is human readable language. Okay, now you see all these steps. Okay, now here this blood pressure signal, okay, what was this? It was what? It was the measurand. Okay, measurand. Okay, this is the measurand. Okay, now in other device this measurand will change, but again that thing will again go through the sensor. Okay, so that will go through the signal conditioning device, that will go again through the ADC, okay, the algorithm and the display. Okay, so why did I talk about blood pressure monitor? This input, okay, so basically we have input, we have sensor, we have processing, right? This processing which converts, which removes the signal conditioning, which deletes the noise and increase the amplitude. Okay, we call it as conditioning. Okay, this processing we also call it as conditioning. Okay, and it goes through a lot of these things. Okay, then output, okay, the human readable output, the desired output. Okay, so it is, this is same for in all medical instruments. Okay, so this is the reason we talk about this blood pressure monitor. Okay, so for example in blood pressure monitor, what is the pressure sorry, this measurand, the measurand is pressure, right? Arterial pressure. Now in the USG, what is the measurand is sound wave reflections from tissues. Okay, now in ECG, electrocardiograph, what is the measurand is electrical potential of heart. Okay, now in pulse oximeter, light absorption by oxygenated blood, that is the measurand. Okay, so this was introduction to medical sensor technology. Okay, now if in case you have any doubt, you can comment, or if you need any help in the medical sensor technology course, you can definitely contact me. Okay, so thank you and see you in the next class.